Friends, how are you? Hope you are fine and everything is working well for you, right? Okay. I just want to say a big hi to all of my brothers and sisters who are on the online. How are you guys? So if you are in online, please say hi so that I will understand like you people are in online, right? How are you guys? Hope you are fine, right? And my voice is also audible to you. So today's session is all about summary of IS 456, about Shear, how to design for Shear as per IS 456 2000 guidelines we will tackle. Right? Today the session is all about numerical problems and how we can apply the clauses of IS 456 to design for Shear we will tackle. Right. Vasant Sai, hi sir. Hi Vasant Sai, how are you? Hope you are fine. And yeah, how are you? Right. Good, 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 good. Okay, today we will see about the numerical problems on design of shear. We will see. And before I start the content, I just want to say like there are so much of free content is already happening in this Unacademy learning app. If you are if you are a student of if you are if you are an aspirant of GATE or ESE or any other competitive examination, brother, then definitely I can recommend you guys this installation of this Unacademy learning app. After you install this Unacademy learning app, you can follow me by using this link which is given below. I hope you are able to see this is the link. Using this link, you can follow me. When you are able to follow me, three advantages are there, brother. The first and foremost advantage is already the free content I had done in an academy learning app you are able to access. And second one I can say is and about second one I can say maybe I can say like in this way. The upcoming free video lectures of mine will be notified to you. And about third one, what about this third one? About the third one, I can say like at the end of each and every free session, you are going to get definitely a notes when you are able to follow me in an academy learning app for special classes. These are the three advantages when you are able to follow me. These three you are getting for free of cost without paying even a single pay, right? Right. Some people will say, sir, is there any course, is there any paid courses there in an academy learning app so that we will get entire content? Because in free classes only for some few content, few topics only we will teach. Na? Yes, there are paid courses are also there in an academy learning app. You can select after installing the Unacademy learning app. You can keep the goal as GATE and ESE. After you keep the goal or target as GATE and ESE, from the main menu, you go to plus courses. After you go to main menu in the plus courses, you are able to see a tab called get subscription. When you press on this tab called get subscription, definitely we are pretty much sure like when you press on this tab get subscription, you are able to access two paid courses. One is plus course and second one is second paid course is iconic course. You are able to see these two tabs of these two. But to get 10% discount for either any of the paid courses, plus course or an iconic course, you should use this code VT10 as the referral code. When you use this code VT10 as a referral code, directly 10% discount will directly come to you, brothers. Some people will say, sir, before you teach this plus course and iconic course, first of all, please introduce yourself. Some people may ask, this is my first class, sir. So first of all, please introduce yourself. So coming to that, I am Venkata Tilak. People call me as Venkata sir. Some people call me as Tilak sir. I completed my masters from University of Sheffield, England, and about to complete my doctoral degree, PhD also. My background of education is completely into structural engineering. So here also in an academy platform, I am going to tackle only the structural subjects, ranging from engineering mechanics, strength of materials, structural analysis, concrete structures, steel structures, and finally to construction materials and management. These are the six topics I just did in this Unacademy learning app. And some people will also ask us, sir, what is the specialty of this university from where you had graduated? This university produced six Nobel Prize winners, brother. So you can understand producing six Nobel Prize winners from a university is not a joke. You can understand the depth of research potentiality involved in that university. And moreover, the university ranking of this university globally is always less than 100, which is far better than IITs and IIC Bangalore globally. Right. Some people will also ask us, sir, okay, that is fine. Now, can you tell me here, what is your previous work experience? Previously, I worked as research scientist or research engineer in University of South Carolina for a funded project in USA. For the same funded project, I worked as a team lead also. In addition to this one, previously I worked as head of the Department of Civil Engineering also in an engineering college. This is in India. That means I have both local experience and also global experience also. Coming to my teaching experience, totally I have 12 years of teaching experience in teaching GATE and ESE in different coaching institutes all across India. Right. Being a structural engineer, even till today also I am working as an independent structural design consultant. I personally give structural drawings to my clients, and I personally give structural drawings, and I personally give material testing reports to my clients. There are two things I do in addition to teaching. Right. Some people will say, sir, there are two courses you mentioned. Okay. First of all, please tell me again how, with the help of a screenshot, can you tell us how we can take the paid course after you install the Unacademy Learning app from the Play Store, right? You can install. After you install this one, select your target as GATE and ESE. After you select the target as GATE and ESE here, this is the main drop down menu. From the main drop down menu, you move to plus courses. When you move to plus courses in the from the main drop down menu, then I can definitely say like you are able to see a tab called get subscription. Get subscription. When you press on this get subscription, definitely you are able to go to the paid courses in detail. Some people will say, when you press on this get subscription, how the screen will be visible to us, sir. This is how the screen is visible to you when you press the get subscription. ESC and gate subscription, ESC and gate subscription. There are, I hope you are able to see two courses, plus course and iconic course. For plus course, for 12 months duration of subscription, the cost after 10 percentage discount. How you can get the 10 percentage discount? I hope you are able to see. Do you have a referral code, faculty referral code? Here you type this code VT10. When you type this code VT10 and when you press up, when you press proceed to pay, then definitely when you are able to see that cost is instead of this 30,250, it has got decreased to 27,225. Definitely, and you can proceed to pay. You can pay when you had taken this subscription duration more than 6 months, then definitely no cost EMI is also available. So you can have a no cost EMI also, and you can pay that stuff, right? This is for plus course. Now coming, some people will say, sir, what about the cost for iconic course? Coming to the iconic course, for 12 months duration of subscription, the cost after 10 percentage discount, after applying this code VT10, the cost after 10 percentage discount is 45,225. This is for 12 months course. Some people will also ask us, sir, what are the benefits that I will get when I had taken the subscription? Definitely the benefits. So coming to the benefits, either for plus codes and iconic codes, I will tell the difference also. But commonly for plus codes and iconic codes, these are the four benefits to common benefits. First benefit is instant doubt resolution. You can directly chat with the educator in every daily live class. You can directly chat with the educator, and the educator will resolve all your doubts with the help of polls. So instant doubt resolution is the first and foremost advantage. Coming to second advantages, we are supporting you guys with the help of test series also. So through test series, you can write online quizzes, online test, subject wise test, mock test, grant test, and all different tests you can write, and you can evaluate at what level you people are when compared to the topmost students of an academy. And you can improve your, definitely you are able to improve your performance if you are lagging your performance in some of the subjects or maybe in some of the topics, definitely. And the third advantage is, brothers, there is no need to plan yourself. We will provide the entire plan. If you stick to that plan, definitely we are pretty much sure like you are able to get very good rank, because we are preparing this lecture plan in such a way that so that even the below average student can cope up with our lectures. That is our major motto. And the final advantage is, on some of the days you may not access the thing. In such case, you will be provided with the same access. Then you will be provided with this. Then you will be provided with the same access of the live lecture in the form of recorded version, right? And you can access the same recorded lecture maybe by mobile phone or maybe by a tab or maybe by PC, depending on your comfort. You will get unlimited access to all the lectures also. These are the four advantages. Some people will say, sir, what is this iconic course? This is in iconic course, there are two more extra benefits will be there. The fifth benefit in iconic course is you will be provided with a personal mentor. The personal mentor will track all your performance and he will resolve all your doubts, and he will every day, every week he will tell you like, this is how you are performing, you need to improve in this way. So definitely you will have some personal tutor indirectly. A personal mentor will be provided to you, and you can ask all your doubts directly to him. And the sixth advantage is, in this iconic course, especially if you buy this iconic course, you will be provided a special notes, I can say, special notes from an academy. So these two are not special notes, is not directly given by an academy when you had taken the plus course. These are the two benefits which are extra when you had taken this iconic course. So any course is good to crack any of your competitive examination for sure. So shall I? This is the advantage when you had taken the paid course. These are the disadvantages you will not get when there is a free subscription. These are some of the top course educators that we have directly in Unacademy Learning app. You can have a directly look in the app also. And coming to the course language, the courses will be taught separately in English separately and also in Hindi separately. So there won't be any language barrier. The guys who are comfortable in Hindi, they will listen to the Hindi classes. The guys who are comfortable with English, those guys will listen to English classes. So there won't be any language barrier also. When you had taken this subscription, paid subscription, you will be provided access to all the courses in your particular stream. Till now in GATE and ESC, till now we people had launched 8 courses. Out of 8 courses, few courses are long term courses, few courses are short term courses. But when you had taken subscription, for the duration of subscription, you will be provided access to all the courses that are launched in your particular stream, like civil engineering. And yes, I just want to convey one thing. Every day my class is happening in Sun Academy Learning and in this Let's Crack Gate and ESE Civil YouTube channel. Every day my class is happening by 11 a.m. Don't miss my classes, and I can recommend even Kamalakar Sir Pandey's classes also. His class is happening every day by 9 a.m. in the same channel. Right. And last but not least, before I start the session, you are getting all this for free of course. Please like our videos, share our videos, subscribe to our YouTube channel. Let's Crack Gate and ESC Civil YouTube channel. Right. And don't forget to press the bell icon. If you press the bell icon, the future coming videos will be notified to you. In such case, you will not miss even single video. When you say the same thing to your friends, they will also get benefited because this content is at least free. You are doing some benefit to your friends also. And for your convenience, to solve your doubts, I already started a Telegram group, and the name of the Telegram groups are Let's Crack Gate and ESC. And another name of the Telegram group is this one, Unacademy underscore Simranjit Tilak. If you come down to this Telegram group, use this link which is given below. When you press this link, definitely you guys will be redirected to our Telegram channel. You can post your doubts there. We will take care of your doubts. Okay, so shall we start the session, brothers? Yes, I just want to start the session, brothers. Yes, the session is all about using numerical problems or using some questions. You are going to learn the concept. That is the major thing, right? So let me start teaching you. I hope today's the design is how to design for shear, right? So in this today's session, with the help of clauses that was given in IS 456, we will work out the numerical problems. numerical problem. Before I start numerical problems, for maybe 2 minutes or 3 minutes, I just want to say the theory that is required for this problem. Is that okay, brothers? So if that is okay, I just want to, yeah, I just want to say, right, let me have a, let me, so some people had a lot like, I just want to give some small information before I tackle this numerical problems. I hope if you know, even tau v is equal to nominal shear stress. Nominal shear stress. When tau v and tau c stands for shear strength of RCCB. RCC section, which is a function of FC, grade of concrete, percentage of tension reinforcement we call, right, which we call it as 100 AST by PD. Generally we write in this, right. Here there are several conditions how we can design for shear reinforcement. We can design the shear reinforcement by providing vertical stirrups or inclined stirrups. In the form of stirrup reinforcement, we generally resist the shear. Okay, now the question is that how to design for shear reinforcement. There are different clauses were there, brother. The clauses were when tau v is less than or equal to 0.5 times of tau c. In such case, you can say like there is no need of minimum shear reinforcement is also required. That means the developing stress is very less than, is 50 percentage less than the strength of our shear strength of RCCB. In such case, there is no need to provide minimum shear reinforcement also. I can say like no need to provide at least minimum shear reinforcement. This is what I can say, right. Next condition, like some people will say like, sir, I just want to rub the screen. If you want, you can take the screenshot till now. Some people will say, sir, what let us suppose there is another condition. If I go like when tau v, developing nominal shear stress is more than zero point 0.5 times of tau c, and less than or equal to tau c. In such case, I can say the section is safe in shear. Section is safe in shear. There is no doubt. But in major designs, we generally don't consider the secondary effects, the stresses that are coming into picture because of temperature, because of shrinkage, because of creep. We don't generally consider in calculations. Generally, to take care of those secondary effects, with the code says is you, even when tau v is greater than zero point 0.5 times of tau c and less than tau c, even though still it is safe in shear, but still you provide some nominal or minimum shear reinforcement. The code says section is safe in shear. Okay, it will not fail in shear, but to take care of secondary effects like stresses due to temperature, shrinkage, creep, etc., provide nominal, I hope you can say nominal says minimum, nominal or minimum, provide some nominal or minimum shear reinforcement, RFT we can say. Some people will say, sir, how to provide this minimum shear reinforcement, sir? People generally will ask us, right? So the code says you need to provide the shear reinforcement in the form of vertical steps only, in the form of V stirrups, because vertical stirrups are more stable when compared to inclined stirrups. Vertical stirrups are more stable, so that's the reason why code says use vertical stirrups. But in terms of shear reinforcement strength, inclined stirrups will provide more effective, but it is not stable. Inclined stirrups are not stable. in the cage reinforcement. So that's the reason why the code says to use the vertical steps when you are designing for, I can say, when you are designing for minimum shear reinforcement or nominal shear reinforcement. Okay. I hope you had taken the screenshot even till now also. Okay, let me rub the screen. If I erase, now the condition is, sir, when tau v is more than 0.5 times of tau c and less than or equal to tau c, in such case, how to design this nominal shear reinforcement? Everybody will ask us. So coming to this nominal reinforcement or shear reinforcement, we can write as ASV. Using this equation, we will design the shear reinforcement, nominal shear reinforcement, minimum or nominal shear reinforcement. So ASV by, I will explain each and every time, ASV by B into SV is equal to 0.4 by 0.87 Fi. Generally, I will fix the cross-sectional area of the vertical stirrups. If I take a vertical stirrup as this is a two-legged, a 8 millimeter dia, 8 millimeter dia mild steel stirrup. Then the cross-sectional area of this two-legged mild steel 8 dia strips, the cross-sectional area is known. What is ASV? Area of shear reinforcement. So what is the cross-sectional area of ASV? Cross-sectional area of the shear reinforcement. If the example is two-legged 8 millimeter dia strips, na. So there are, this is one, this is one. So two cross sections are there. So 2 into pi by 4 into a square. 8 square. That means I know this. B stands for the width of the section. B stands for width of B. This is stirrup. Okay. Right. SV stands for the spacing of shear reinforcement. Which is spacing here in this above formula? Spacing of minimum shear reinforcement. Spacing of minimum shear reinforcement, I can say. Now here Fi stands for yield strength of shear reinforcement. If I say the yield strength of shear reinforcement out of HYSD bars and mild steel reinforcement, mild steel reinforcement is good for shear reinforcement because it provides more ductility. So and generally to achieve more ductility here, for shear reinforcement we need to provide mild steel straps. So generally, if nothing was given, we generally do the design with the help of mild steel straps. So maybe Fi I can write as 250. So in this case, the one and only unknown is SV. ASV I know, B is known, SV I don't know. The spacing of minimum shear reinforcement, that spacing I don't know. So from this equation, I am able to work out the spacing of minimum shear reinforcement. I am able to work, isn't it or not? When I am able to work out the spacing of minimum shear reinforcement, SV of spacing of minimum shear reinforcement, there are certain clauses were there. If you got the spacing of shear reinforcement as 1 kilometer, will you provide? If you got the spacing of shear reinforcement as 2 millimeter, will you provide? Those are awkward, right? So the spacing of shear reinforcement maximum value should always be less than or equal to 300 millimeter by using vertical stirrups. This should always be less than 0.75 times of t. So this is how we can say. Some people will say, sir, this is how you are able to design the shear reinforcement. You fixed the diameter, number of legs for vertical straps, and you are able to work out even this spacing, and you are comparing the spacing. Okay, now some people will come and say, like, sir, coming to the third condition, when developing average shearing stress, tau V is more than tau C and less than or equal to tau C. Coming to this tau C max, it is the maximum shear strength of concrete, I can say. Shear strength of concrete alone. Some people will say, sir, how to work out this? And this coming to this tau C max, this tau C max is equal to, we can write as 0.25 times of root FCK as per limit state method. As per working stress method, we can take it as 0.16 times of root. the 0.11 times of FCK, sorry, 0.1 times of FCK. So this is how we can work out this tau c max. And actually, to be frank, this tau c max values were also tabulated, if you see, in IS 456 tabular form also. I just want to give to, to be frank, I can say this is from table 20 of IS 456. So there is no need to memorize this one also. And tau c, you can work out, it's a function of FCK and percentage of tension steel. You can work out this tau c from table 19 of IS 456. For your competitive examinations, don't worry, they will give this value because the code of practices is not supplied to. So generally this data will be given. Don't worry, there is no need to mug up anything, right? Yes. So when you do this one, here how to design for shear reinforcement. You can design the shear reinforcement here. Let's say can design the shear reinforcement. We can say one is by vertical stirrups, second one is by inclined stirrups, third one is by bent up bars. By using these three ways, you are able to design the shear reinforcement. Okay, some people will just say that is fine, that is okay. Now how we can design the shear reinforcement by using vertical stirrups when for this condition number 3, which is when tau v is greater than tau c, when the tau v is greater than tau c. Okay, so I hope you can take the screenshot also. I'm just rubbing the screen. Is that okay, brothers? So okay, condition is to case 3 where tau v is greater than tau c, less than or equal to, right? In this case, by using vertical stirrups, I am using vertical stirrups. Using these vertical stirrups, how I can design the shear reinforcement. In case of designing the shear reinforcement, I need to select the diameter of the stirrup, and I need to mention whether it is two-legged stirrups or four-legged stirrups, or just it is a hook-like one-legged stirrup. Just I need to mention the number of legs and the diameter of the stirrup also, right? And I need to mention, I need to fix the spacing of the shear reinforcement also, right? These are the three things I need to fix in case of design of shear reinforcement. Now coming to the design of this vertical steps, you can say like, sir, if what is the question is developing shear, if the shear force maximum acting on cross section is VU. Some people, if the shear force acting on the cross section is VU, what is the shear strength of this section? How you can say the shear strength of RCC section, brother? So shear strength of RCCB. How you can write shear stress of RCCB, which is tau c into cross sectional area of RCCB. Maybe I can say B into D. It is the thing. Now, what is the shear force for which I need to design the shear reinforcement, especially? So shear force for which reinforcement Vus is equal to 0.87 Fy ASV into D by SV. You know VUS, this is known to you from this one because these two are given now, so we can work out VUS. Fy, I mean yield strength of the stirrup reinforcement, I mean shear reinforcement, maybe 250. Or what is ASV? Cross sectional area of shear reinforcement. What is the cross sectional area of the shear reinforcement, brother? If it is two-legged, so n into 5 by 4 into phi square. So number of where n stands for number of legged stirrup, 5 by 4 into phi stands for diameter of stirrup. So you know ASV also. What is D? Effective depth, right? Effective depth is also known from the given problem. The dimensions will be given. The one and only unknown is SV. So from this one and only one equation, can I work out the spacing of shear reinforcement or not? So if you provide that spacing, that diameter of the stirrup, two-legged diameter of the stirrups of 8 millimeter or whatever that may be, you are able to fix this spacing, right? So from this one, SV can be found out. But will you provide this spacing directly? No, no, no. I just want to convey one thing. Always I work out this SV should always be less than or equal to spacing of minimum shear reinforcement. Minimum shear reinforcement. I already teach you how to find the spacing of minimum shear reinforcement. This SV should always be less than, if it is by vertical steps, it should always be less than 0.5 times of T. It should always be less than 300. This is how I need to work. I need to develop the spacing of, I need to design the spacing of shear reinforcement. Is that okay, brothers? Can I rub the screen? Just allow me 2 more minutes. So we are able to complete the theory, and we can go to problems. Okay. Yes. I just want to rub the screen. Right. So let me erase. Some people will say like, sir, here you mentioned in your previous slide, like you can design the shear reinforcement by vertical steps, by inclined steps. Sir, for the same thing, if VUS is equal to VU minus tau C times of BD, this is fine, right? This is fine. I want to design the shear reinforcement using inclined steps. If the design is by inclined steps, like how you can say about, if this is the beam, for example, this is main reinforcement, this is main reinforcement, and this is how the shear stirrups, like inclinedly way stirrups are there, right? These are inclined stirrups, inclined stirrups. The angle made by this inclined stirrup with the axis, I hope you are able to see the axis of the beam. If the angle made by this inclined stirrups with the axis of the beam, this is axis of the beam, is alpha, right? In such case, how I can work out the spacing of this inclined stirrups? SV of, I can say, inclined in such way. So in such case, I can write as VUS is equal to, just previously whatever may be the thing that I used for vertical stirrup, same equation I can use, like 0.87 Fy ASV into D by SV. We will write as it is. But there, this is stirrup. It is making angle some alpha, na? So extra thing that will come into, that will come into equation for inclined stirrups. For inclined stirrups is sine alpha plus cos alpha. Is the extra element that will come into picture for for inclined stirrups. But this terminology is one for inclined stirrups, because for vertical stirrups, alpha is equal to 90 degrees. Na? For alpha is equal to 90 degrees, then it is vertical stirrup. Then sine alpha plus cos alpha is equal to 1, right, in that particular case. So this is how we can work out. And you know VUS, you know Fi maybe 250, ASV. So it is two-legged stirrups now. So I can write N into pi by 4 into diameter square. Two-legged 8 millimeter stirrups or something. D is effective depth. SV. This SV is the spacing of the shear reinforcement. I don't know. I need to design that spacing of shear reinforcement na? By using this inclined strips. I don't know. Alpha, cos alpha will also be known. Okay. So from this one, I can work out this spacing of, what is this spacing? Spacing of inclined strips. Okay. The spacing of this inclined strips should always be less than or equal to spacing of minimum shear reinforcement. One thing, shear reinforcement. It should always be less than or equal to 300. It should, coming to, this is inclined strip. No, the spacing should be less than, I can say, as the small effective 1 times of d for inclined strips. And this is how we can deal this one. So shall we go to the problem, brother, directly? I just want to work out the problem, right? Maybe let me just rub the screen, brothers. Here, erase all the ink, and here also let me just erase all the ink. Now you are able to see this question, right? A reinforced concrete beam of rectangular section of breadth is how much? Of breadth 250 milli 230 millimeter. Okay, they are saying the breadth of the section is 230 millimeter. Fine. So I can write B is 230 millimeter. I am not trying any sketch. I am just writing everything, the data in terms of notations. Okay, and the effective depth, which we people call it as small d, it is 400 millimeter, and it is subjected to a factored shear force, which is called as factored shear force. It is limit state method, which is VU is equal to 120 kilonewton, right? The grades of concrete is M20, so I can say FCK is 20 megapascal, and grades of main steel is 415, and stirrup steel is 250. I just want main steel. Just want stirrup steel, na stirrup steel. So Fy of shear reinforcement is 250 kappas. Uh, for uh, for for the area of main steel provided, the design shear strength tau c, that is design tau c shear strength of RCC beam for IS 456 2000 is 0.48. They are giving that as the design shear strength of RCC beam is 0.48. The strength of RCC, that beam is designed for collapse limit state. Okay, they are expecting what is the spacing of 8 millimeter diameter two legged stirrups to be provided. Okay, so they are saying number of legs n is equal to 2, and diameter of the stirrup is 8 millimeter. In such case ASV is equal to 2 into pi by 4 into square. Now, some people will also ask us, sir, shall I use case 1, case 2, or case 3? To compare case 1, to understand whether it is case 1, case 2, or case 3, I need to compare tau V and tau C. So, can I work out tau V? Tau V is equal to average shear stress developed, which we people call it as maximum factored shear force by cross sectional area, which is B into effective depth D, which is nothing but shear area. The VU is 120 kilonewton, so I can write 120 into 10 cubed by B is 230 millimeter into effective depth is 400. So this answer is Newton per millimeter square. Newton per millimeter square. Okay. Now after we do this, this is 1.304. I can say Newton per mil. Here in this case, in our present problem, tau V is greater than tau C. When tau V is greater than tau C, then definitely you should understand, like I need to design the shear reinforcement, right? Need to design the shear reinforcement. So it comes under case 3. Okay, fine. So can I use the next slide to design the shear reinforcement, brother? Yes. So I can say what is the shear force to be resisted by shear reinforcement? VUS. Shear force to be resisted by shear reinforcement. Shear force acting on the cross section minus shear strength of the cross section, which is tau c times of B. Bu, it is already 120 in 10 cube Newton, I can. And tau c, it is 0.48, and times of B is 230 millimeter, and effective depth is 400. Then you will get in terms of Newton. So if you say it is 75840 Newtons, this is the shear force to be resisted by shear. Let me write that shear force to be resisted by shear force to be resisted by shear. Okay, That is fine. Now, here how to work out the spacing. I hope I had already VUS is equal to 0.87 Fy ASV into D by this is by using vertical steps. Right, the angle of the syrups is not given, so you can treat it as vertical step by SV. Right, so this VUS is how much, brother? This VUS is 75840. Right, and this Fy, this yield strength of this shear reinforcement is it was given as 250 megapascal because it is mild steel, right? ASV, I hope you know ASV is 2 into pi by 4 into 8 square, and coming to effective depth is 400. So in this one, the one and only unknown is SV. So if you work out this SV, the answer of SV is equal to 115.32, but I cannot directly conclude this one. SV should always be less than spacing of minimum shear reinforcement. One thing, this should be less than or equal to 300. This should be less than or equal to 0.75 times of effective depth D, which is these two conditions are satisfied. I need to work out the spacing of minimum shear. Is that it all? So can I work out the spacing of minimum shear reinforcement, brother? Yes. How we can work out the spacing of minimum shear reinforcement? ASV by D into SV is equal to 0.5, 0.87 F. We can write in this way. ASV, how you can write? 2 into pi by 4 into 8 square. B is, I think, 230. B 230, na? 230 millimeter. SV. This is SV of minimum shear reinforcement. This is the spacing of minimum shear reinforcement. This SV minimum equal to 0.4 by 0.87 Fi 50. So if you do this one, generally this SV will also be almost the minimum is generally it will be greater than, definitely it will be greater than 115.3. So finally I can come to a conclusion like the minimum value is 5.32. So out of all these options, brothers, na, which option you can pick, brother? 115.3. I can pick 115 millimeter with the correct option. So I can go for B for Boston is the correct option, isn't it or not, brother? Right? Is that okay? Is that okay, brother? So shall I move to the next question? Right? Yes, moving to the next question, brother. This is the next question. A reinforced concrete beam. I think the say yeah, a reinforced concrete beam of rectangular cross section B and D, of course. Same previous problem. Problem is one and same. I mean, statement of question is one and same. B and effective depth is 400 millimeter and factored shear force, which we people call it as 120 kilonewton. The grades of concrete, okay, grades of concrete is FCK is 20, and main steel is okay, Fe 4 and 5, whereas stirrup steel is 250. So I can say Fy of shear reinforcement is 250, right? For the area of main steel provided, the design shear strength tau c. So tau c is 0.48 Newton per millimeter square. To be frank, I need to work out this tau c from table number 19. But here it's a competitive examination. Na? So generally, the value of tau c will be directly given to you. The beam is designed for. In addition to this one, the beam is subjected to a torque, which is called as torsional moment. Okay, the torque or torsional moment, whose factored torsional moment is 10.9 kilonewton meter. Right? I just want to, when in addition to this shear force, in addition, if this is the cross section, if cross section is subjected to a shear force, okay, cross section is subject to a shear force V. and this cross section is also subject to a torsional moment. Torsional moment is always possible about the polar axis of the cross. This is polar axis of the cross. I can say this is a torsional moment. 10.9 I can write, right? If this is the case, I just want to convey one thing. Using skew bending theory, if torsion is acting on the cross section, then there is no separate design for torsion. If a cross section is subjected to torsion, design that RCC section for increased shear force and increased bending moment. Now coming to the equivalent shear force, because of the action of this torsional moment, everybody will ask, right? Yes. So if we is the equivalent shear force. How I can write this equivalent shear force is factored shear force plus the shear force that is coming into uh, torsional moment. So plus shear force developed due to torsional moment. This is VU. What is VU? It is a shear force developed due to loads. Shear force factor. Factored shear force transverse is equal to this. Yes, we can write. Coming to VU. VU, it was given as 120 kilonewton. Plus extra shear force developed due to torsional moment. If you refer to IS 456 2000, it was given as, for limit state method, it is given as 1.6 times of du by b. This is the extra shear force, that the extra factored shear force that has got developed because of due to torsional moment. Is that okay, brother? So in this answer, it is 120 kilonewton plus 1.6 times of TU. Factor torsional moment. The factor torsional moment is, I think it is 10.9, 10.9 kilonewton meter. So the width of the beam should also be in meter. Width of the beam, it is 230 millimeter. Coming to meter, it is 0.23 meter. So if you cancel out meter and meter, definitely you are going to get this equivalent shear force. The equivalent shear force is 195.83 kilonewton. Right? Now, what is the question, brother? I hope you are able to see. The stirrups have been, the question is, what is the shear force that needs to be resisted by the stirrups? Shear force have to be provided to carry a shear. So indirectly they are expecting what is the shear force to be resisted by the stirrups. Let me write shear force to be resisted by shear stirrups or stirrups. How you can say, on the cross section the total developed shear force is equivalent shear force V, right? So this is called as VUS. Is VE minus the shear strength of RCC beam. How we can work out the shear strength of RCC? It is tau C is the shear strength of RCC beam in terms of stress multiplied by cross sectional area BD. If you are able to work out this, right? What is this VE stands for? VE equal to 195.8 Newton minus tau C. And coming to tau C, how you can directly write the tau C? Tau C value is given in the problem. It seems like 0.48, I think. Yeah. 0.48 is 0.48 Newton per millimeter. So let me write minus 0.48 Newton per millimeter square into B is 230 millimeter. Effective depth is 400, right? So B into D is this one. You will get this answer definitely in terms of Newton. But I want this in terms of kilonewton. Na? So totally divided by this value divided by 1000. So this tau c times of BD will also be in kilonewton. When you work out this one directly, this answer is 151.667 kilonewton. This is the answer for which, this is the shear force for which I need to design the shear reinforcement. So can you pick this option as 151.67? Yes. So I can pick option C is the correct one. Is that okay, brother? Is that okay? Right. Right. Can I move to the next question, please? Right. Can I move to the next question? Right. Please say yes or no. Right. Okay. Moving to the next question. I hope you guys are able to see the next question. A reinforced RC beam of width 250 millimeter effective depth. So this B is 230 millimeter and the effective depth, which is small d, it is 450 millimeter, is updated to a factored shear force, which we people call it as B, 50 kilonewton, and M20 grade concrete is used for the beam. So it is FCK, it is 20 megapascal Newton per millimeter. Right, maximum allowable shear stress, that is tau c max. Maximum allowable shear stress is, they are saying it as tau c max, and the value of the tau c max is 2.8 megapascal. Right, the shear resistance of the beam, that is shear strength of the beam, which we people call it as tau c, which is shear strength of the beam, 0.75 megapascal. For shear reinforcement of 8 millimeter diameter, okay, so I can say for shear reinforcement, two-legged mild steel stirrups, okay. Spacing of reinforcement, what is the spacing of shear reinforcement? So coming to area of the shear reinforcement, it is a two-legged stirrups now, so 2 into, I can write pi by 4 into diameter square. The diameter of the shear reinforcement is 8 millimeter diameter. I can write 8. This is how I can write 2 into pi by 4 into 8 square. Right. If this is the thing, now the question is, yeah, they are expecting the spacing of shear reinforcement. Work out spacing of shear reinforcement, there are three conditions are there. So to understand about the condition, which correct formula I can use, I need to compare between tau v and tau c. Tau c is already given to me. I need to work out tau v, right? How I can work out tau v is equivalent shear force by BD, or a factored shear force that is developed on section, which is 50 into 10 cube Newton by by B into D. B is 230 millimeter to effective depth is 450 Newton per millimeter. How we can do. Now, if you do this, the answer for this one is definitely 0.48 megapascal. Right. Here, this value of tau v, here tau v is more than zero point 0.5 times of tau v is more than zero point 0.5 times of tau c, and tau v is less than 1 times of tau c. This comes under case 2. So here I need to provide minimum shear reinforcement is, I mean, the section is safe in shear, but to take, I need to provide some minimum shear reinforcement to take care of secondary effects, right? Need to provide minimum shear reinforcement. So can I do that? How can I design that minimum shear reinforcement in the next slide, brothers? So can I design that minimum shear reinforcement in the next slide, right? So yeah, I'm using next slide. Design that minimum shear reinforcement. So what is the equation that we can use for minimum shear reinforcement? It is ASV by B into SV equal to 0.4 by 0.87. So coming to ASV, how we can do this ASV, brother? ASV, it is the area of cross-section area of the shear reinforcement, which is two-legged stirrups now. So 2 into, what is the cross-section area? What is the diameter of the single leg? Is 8 millimeters. So 2 into pi by 4 into 8 square by B. the width of the beam, which is 230. So this is the spacing of shear reinforcement. Na SV minimum shear reinforcement. I can write is 0.4 by 0.87 F5. What is the grade of stirrup steel? The grade of stirrup steel is mild steel. It was clearly given. Yeah, mild steel stirrups are used. So when mild steel stirrups are used, here I need to provide this is so from this one I can work out SV, which is equal to 237.7 million. But I cannot finally conclude this one. This SV minimum shear reinforcement should be less than 300 millimeter, should be less than, it is by using vertical steps. Now this should be less than or equal to 0.75 times of 0.75 times of d4. So in such case this should be less than or equal to how much it will be, 337.5 millimeter. What is this SV minimum? It is 237 na? Let me this is 237.67 millimeter. So I can say like it is satisfying the conditions of, finally the answer is 237, 235, like that I need to provide. So let me show, let me see. The options are 100 millimeter, 150, 175 and 230. We got actually 237. If it is more than 237, it is a failure. What is the nearest lesser value? Just nearer to 237, it is 230 millimeter. Directly I can pick option D for Detroit is the correct option. Is that okay? Is that okay, brother? Can I move to the next slide? Right? Next question, I mean. So moving to the next question. I hope you are able to see this question. The above problem, that is the same problem in the above problem. If the factored shear force is changed to 100 kilonewton. So instead of 50, it has got changed to U is 100 kilonewton. And remaining data is one and same, brother. Like tau c, all this stuff. Tau c, what is the value of the tau c in your previous problem? Value of this tau c is shear strength of beam 0.74, right? The same data I am trying to take. Tau c is 0.75 and tau c max, maximum shear strength. It is how much? Which is how much? This is 0.75 Newton per millimeter square. And I can say is tau c max. What is the value of the tau c max? It is 2.75 or something. Yes. Now I need to compare between tau v and tau c. Tau v is the nominal shear stress. Nominal shear stress or average shear stress. Nominal or average shear stress. If it is that one, directly we can write Vu by Vd. What is that value of Vu? 100 into 10 cube by V. Width is 230 millimeter and the effective depth D is I think is 450 millimeter for the previous problem. So I am taking the same thing because in the above problem they mentioned. So if I work out, this is 0.966 megapascal. Here tau V is greater than tau C and less than tau C max. So I can say need to design the shear reinforcement. Need to design the shear reinforcement, right? Need to design the shear reinforcement. If I need to design the shear reinforcement, how I can design this shear reinforcement? By using this wood stirrups, brother, 8 mm diameter mild steel stirrups. Okay. So I just want to write, before I need to design the shear reinforcement. What is the shear force for which I need to design the shear reinforcement, which is VUS, right? If VUS is the shear force to be resisted by the shear reinforcement, VUS is equal to VU minus tau C times which is VU is 100 kilonewton minus tau C is 0.75. I can write this one as 0.75 Newton per into P. P is how much, brother? 230 milli. T is 450 millimeter divided by 1000. Then I will get this in kilonewtons. Then definitely, if you work out, this VUS will be 22.375 kilonewtons. VUS will be 22.375 kilonewtons. This is the shear force for which we need to design the shear force. So I am using next slide. Yes, Jelani Basha. Hi sir, how are you? I am fine, brother Jelani. Oh, how are you? Hope you are also fine. Yeah, right. Shall I work out? Now for these problems, you tell me if the VUS is this much, how to work out this spacing by using this vertical stirrups. Use this equation. VUS is equal to 0.87 Fy ASV into D by SV. So VUS, how much we got? It is 22.375. So in terms of newtons, it is 22375 Newton. And coming to Fy, Fy is Fe 250, na? It is 250. ASV, it is 2 into 5 by 4 into 8 square. Effective depth D is 450 millimeter. So the one and only unknown is SV. Can you work out SV spacing of the shear reinforcement, brother? If you work out the spacing of this shear reinforcement, what will be the answer, brother? So you will get this answer definitely in millimeter, because I had taken the force in Newton and distance in millimeter. So SV is spacing now, which is 439.75 millimeter. But you cannot directly fix this option. Directly you should check like this SV should be less than minimum shear reinforcement spacing. SV, the spacing of this shear reinforcement should be less than or equal to 300. Spacing of this vertical stirrup reinforcement should be less than 0.75 times of D, which is how much you got? It is 337.5 millimeter. And in your previous question, what is this SV minimum? What is this minimum shear reinforcement that you got this answer in your previous question? The minimum shear reinforcement spacing is 237.67. Even though you got the spacing from the equation is this much, this value should be less than this one. Na? So definitely you need to provide. So I can say like shear reinforcement, provide shear reinforcement with spacing 237 millimeter. So if I go to the options here in this question, options are 100, 439 is also there. This we got by equation, but you should not pick this one. 230, 300 is there. So the correct option is I can 237 less than or equal to 237. Nearest option is 230 millimeter. You can pick this option. You pick this option. If you pick this option B or D, then you are making some wrong decisions, right? That is how you should understand. So can I move to the next question, brother? Yes. Moving to the next question. I hope you are able to see in the same above problem. The same above problem with the factored shear force. So in the same above problem means SV minimum. What is the minimum shear reinforcement that we got for above problems? Is 237.67, right? And VU is 150 kilonewton. Okay. It supports two bars of 16 millimeter diameter. So they are saying, okay, they are saying here this shear, there is a beam is there. At the support, two bars were bent up. So this is the main steel. but at the supports, two bars were bent up in this way. I already mentioned by using bent up bars also some shear force will also be resisted, right? So let I can say some people will say, sir, what is the shear strength of a bent up bar? How we can work out the shear strength of bent up bars? Maybe I can say if PUS1 is the shear strength of bent up bars. If US1 is equal to shear strength of bent up bars, then definitely I can say like, okay, what is the equation for shear strength of bent up bars, brother? It is 0.87 Fy ASV into sine alpha. Fy ASV into sine alpha. What is ASV? It is the cross-sectional area of the bent up bars is nothing but here is ASV. Two bars of 16 millimeter diameter are bent up at the supports. Here this cross-sectional area is ASV and it supports two bars of 2 into 16 millimeter diameter was bent 2 into pi by 4 into 16 square, right? And Fy, what is that Fy, brother? Fy is it is Fe 4 and 5 bars were bent up because the bent up bars are main bars, right? So I should not write 250 here. I should write uh, Fe 4 on 5. Fe 5, right? Alpha. At what angle these bars are bent up? If the angle is not mentioned, generally I can these bars are bent up at an angle of 45 degrees. This whatever may be, which is 45 degrees. Value is not given. Generally, you can consider it as 45 degrees. Sir, if it is possible, please answer mine, sir. Okay, okay. You are talking about a question that you sent now, so I will answer that one, brother. Because yesterday I'm a bit busy. In the morning only I had seen. I will answer your query. Don't worry, please. Right. So if it is ASV is known, Fi is known, sine alpha, it is sine alpha is sine 45 degrees is known. If you work out this one, you are going to get this answer as 102.66 10 to 10 cube Newton, 102.66 kilonewton. But there is one more clause is there, brother. Like the shear strength of bent up bars is limited to 50 percentage of maximum shear force acting on the cross is there. Like the shear strength of bent up bars VUS1 should not be more than is at max it is limited to 50 percentage of factored shear force acting on the cross section, which is 0.5 times of shear force to be resisted by should not be greater than VUS1 should not be greater than 50 percentage of shear force to be resisted by shear reinforcement, called as 0.5 times of VUS. What is VUS here? Shear force to be by shear reinforcement generally. So coming to if I want to work out this VUS, how I can work out this VUS, brother? Coming to this VUS, which is equal to VU minus tau C times of PD. And VU, what is that value of VU, which is 150 kilonewtons minus tau C 0.75 times of Newton per millimeter into B is 230 and effective depth is 450. We can write this way. This you will get this in Newtons. So divide by 1000, you will get in kilonewtons. So directly this answer will be, I can say 72.375 kilonewtons. I can say. Okay, but there is one condition is there, na? VUS1 is equal to should not be greater than 0.5 times of VUS. The shear strength of the bent up bars at max is limited to 50 percentage of shear force to be resisted by shear reinforcement. So I can write VUS1 is equal to 0.5 times of this is equal to 36.18. Spacing, can say so spacing of shear reinforcement. Spacing of shear reinforcement can be worked out for what? Spacing of shear reinforcement can be worked out for a shear force of 72.375 minus 36.187 is 36.187. So if I call that as that value as VUS2, so I can write VUS2, the shear force to be resisted by vertical stirrups. I can say shear force be resisted by stirrups. I am not saying total entire shear reinforcement. Okay, so which is equal to 0.87 F by ASV to D by to ASV to D by SV. US2, how much is that one? It is 70. It is 36.1875. Then you can say. And coming to F5, how you can fix F5? F5 of shear stirrups is the 250. Was given, right? Was given in the problem like uh, spacing of 8 millimeter diameter mild steel stirrups. So the stirrups used are mild steel stirrups. So this is 250. And coming to ASV, what is this ASV? Two legged stirrups of 8 millimeter diameter. 2 into pi by 4 into 8 square. Coming to effective depth, what is this effective depth? It is 4. So the one and only unknown is SV. From this one, we are able to fix this value of SV, right? So maybe I can say like, uh, can I rub the screen? Can I rub the screen here, brothers? Right. I just want to rub the screen here. So if I work out SV is equal to 271.902 millimeter, right? But if you understand this SV should be less than or equal to minimum shear reinforcement. What is the minimum shear reinforcement for this problem? This should be less than or equal to 0.75 times of effective depth. But the effective depth is D, be less than or equal to 300 milli, right? So I can say SV minimum. What is the value of minimum shear reinforcement for the same problem? Maybe in your previous problems for the same statement, we got the minimum shear reinforcement spacing is it is 237.67 millimeter. This is 0.75 times of D. It is 0.75 times of D. It is 0.75 times of D. Definitely, it will be 337.5 millimeter. So we got these answers. Out of these one, the minimum value I need to take. The minimum value is 237.67. Na? So for this problem also, the spacing you can keep is 237.67. What is the answer that is nearest to 237 or nearest to 237? It is 230 millimeter. Na? So 230 millimeter center to center will be the correct option for your problem, right? So we completed the numerical questions on this shear. So for today's session, I just want to wind up the session. But before I wind up the session, I just want to conclude like there are so much of paid courses are also happening in Unacademy Learning. Paid course, you are free to use this code VT10, and definitely 10% discount will directly come to you, brothers. When you are able to use this code VT10, the doors and windows of Unacademy will be open to you. There is no need to go to Delhi, Bombay, or Calcutta. The topmost faculty of India are available at your doorstep directly through Unacademy, just by using with the help of single code VT10. And coming to the fees for 12 month subscription, the cost for 12 month subscription after 10% discount is 27,225. The cost for 24 months subscription after 10% discount is 39,600. I just want to convey one more thing also. If you want to follow me in an Academy Learning app, you want to get free content, some free content with some notes, you can use this link which is given below. Then you are able to follow me in an Academy Learning app also. I can recommend this 12 months course for the students who are in final year, whereas I can recommend this 24 months to course to the students who are in third year or second year. I can do that. Yeah. Every day my class is happening by 11 a.m. in this Let's Crack GATE and ESE Civil YouTube channel. Every day my class is happening by 11 a.m. So don't forget to come down to my class. And I can also recommend Kamlakar Sir Pandey's classes also. His class is happening every day by 9 a.m. Right. And last but not least, I just want to convey one thing. You are getting all this for free of cost. Please like our videos, share our videos, subscribe to our channel. Don't forget to press the bell icon. If you press the bell icon, the future coming videos will also be notified to you. In such case, you will not miss even a single video that is coming from this channel. Right. For you guys, I already started a Telegram group for you. You come down to this Telegram group, and the name of the Telegram groups are Let's Crack Gate and ESC, or I can say this channel name is Unacademy underscore Civil Engineer Tilak. Okay. If you want to come down to this channel, Telegram channel, use this link which is given below. You press this link, you guys will be redirected to my channel. Whatever may be the doubts you have, you can post your doubts. I will take care of your doubts in this Telegram group. Okay. So please like our videos, share our videos, subscribe to our videos. Thank you very much. Please share the same thing to your friends. Please say the same thing to your friends so that they will also get benefited. Right. Thank you very much. End of the session.